welcome back to the class. How are you all? How was your last session? Have you studied about pH of weak acid, that how we can calculate it? Or like I have already told you that you can do the practice of some of the question related to that topic. So have you done that? Have you do this question or or if any query, so have you posted your question over the forum? So yes, students, in the last session, what we have done that we have studied about that how we are going to calculate the pH of the weak acid. We have studied about the equilibrium part. Okay, so now so what's the thing, students? Like till now, what we have studied about, we have studied about all of the about acids and bases. Now, what's the topic is left in the syllabus for your acid, bases, and salt? We are left with salt part. Fine, that what is a salt or how we can say that the salt is having different types or something like that. Okay, so we are just left with the salt part. We have completed all of the acid and bases. Fine, and even though we have studied that what are the acid bases and how we calculate their pH, and like we have completed all of these. Now students, today we are going to start a new topic that is called as the salts. Now if I ask you what is the salt, so what you will say? Like in Hindi, if we say what is the salt, salt is called as the namak. Exactly, like in our houses we use white salt, which is called as the sodium chloride. So that is also called as the table salt because we use in our house for our cooking purposes and something like that. So we use salt. Exactly. So that is the salt, student. But now if we talk about the chemistry term, that how we say that what is a salt. So, my dear students, if you remember from your last chapter, that is the chemical reactions and equations, so do you remember one of the reaction very, and it was a very important reaction, if I say neutralization reaction? Do you remember that reaction? If I talk about here, it is the neutralization reaction. So what's the neutralization reaction, student? If you remember that what we do, because the thing is that okay, salt, we know that the salt is namak, but if we talk about in the chemistry part or like in the scientific language, so what we say about the salt, that what could be the salt definition? So student, what we can say that the salt is prepared from the neutralization reaction generally. Okay, it's not like that every time, but generally for your syllabus, what I can say that the neutralization reaction is required to prepare the salt. Exactly, that means the that means the acid and base react with each other and they will form the salt along with the water. Fine, so that's the neutralization reaction which you have studied in your in your last chapter, if you remember. Okay, so and even though in the session, maybe in the second or the third video, we have also talked about the neutralization reaction, that when acid and base react with each other, they will form the salt along with the water molecule. For example, if I take the example of HCl reacting with the NaOH, so it will form, that is the NaCl plus H2O. Now, my dear students, if you know what is the NaCl, so this is NaCl is the sodium chloride, and this sodium chloride we use in our houses for the cooking purpose and like that. So it is also called as the table salt. Okay, that means it is, you can say that it is a domestic salt which we use in our houses to prepare food. So that's how you can say that when acid and bases react with each other, they will form the salt. It's not like that only sodium chloride is formed in such a way. We get different type of salt as well, but the condition should be that the acid and base must react with each other and then they will form the salt. Fine, along with the water molecule. And even those students, like if we talk about the standard definition of the salt from the point of view of your syllabus or your examination, that what you are going to write down, see, this one is the also correct explanation, that yes, from the neutralization reaction we get the salt. But if I say that the like in this if you see, this is the strong acid, oh sorry, strong acid and strong base are here. So this base, this metal, this sodium is a metal, and this metal is replacing the hydrogen from the strong acid. Exactly, and that's how the from the replacement of the hydrogen from these acid by the metal we are getting the NaCl, and there is the formation of H2O, and that's how we are getting the sodium chloride, which is called as the table salt. So the standard definition, if we talk about the salt, so we can say that when the metal present in the hydroxide replace the hydrogen from any of the acid, it will convert into the salt. And yeah, it could be also called as the neutralization reaction. And the first of all, the main thing which we study about the salt is just that the salts are of different type. Okay, we'll see that how we are going it as the different type of salt. But yes, generally if we talk about the salt, so we give the example of the sodium chloride. Okay, that is called as the NaCl. Fine, students. Now moving towards the standard definition, so what's the salt is? Salt is a compound formed from an acid, that is formed from an acid by the replacement of the hydrogen in the acid by a metal. Exactly that same thing which I have told you, that when the metal replace the hydrogen from the acid, then there would be the formation of the salt, and that's how we are getting the salt. Fine, students. Now coming towards the that how we are classifying the salt. So students, that the salt has been classified into four categories. There are more, but for you if I tell that it is the four. Now what are those four categories? Fine, so we'll see that. So just a second, I have a video for you, but first of all, I would like to tell you that if we talk about the that four type of salt, so one would be the normal salt. Now you'll say, ma'am, what's the normal salt is? We'll see. Then one is the acid salt. Third is the base salt, and the fourth one is the double salt. Okay, we'll see that what's the difference between all these one by one. We'll see that. Okay, so first of all, if we talk about normal salt, so normal salt generally prepare from the neutralization reaction, students, like neutralization reaction in which you can say the acid and base react and we get our salt. Neutralization reaction, for example, it is just that HCl plus NaOH, and we get what? We get NaCl from here along with the H2O. And similarly students, it's not like that only about only there is the sodium hydroxide and NaCl. There could be any other thing like KOH reacting with the KCl. So what we are getting? We are getting KCl plus H2O. This KCl is again in a potassium chloride, which is also called as the salt. Fine. Now looking at the video, like from this video, we come to know that what are the different type of salts. So we'll see that. Fine.
Classification of salts. Salts can be classified into different types. Normal salts. Normal salts are salts formed
I
by
should zoom it so that my students can see it very clearly. I hope now it is visible to everyone. Okay. So we'll continue from here now.
Complete replacement of hydrogen ion of an acid molecule by a basic radical. Example: NaCl, sodium chloride, Cu.
See students, like what we come to know for the normal salt, so it's a complete neutralization. See student, neutralization means what? That we are getting complete reaction between the acid and base. So what we can say about the normal salt, so the normal salt are those type of salt in which the metal will replace all of the hydrogen. Like we can see that the HCl is having only one hydrogen, so the metal, that is the sodium, is going to replace the one hydrogen, and there will be no any left like you can say that left hydrogen, so that there is any other type of salt can be formed. Fine. So it's just that when the metal replacing the hydrogen from, like there would be the complete replacement of the hydrogen ion with the help of the basic radical. Now you will say, ma'am, what's the basic radical? See, in this case the base is NaOH, so we can write down it as the Na positive and OH negative. So this Na positive will replace this hydrogen, and that's why we are calling it as the basic radical. Fine. So it will replace all of the hydrogen hydrogen from it and form the sodium chloride salt. So that is called as the normal salt, in which the metal replace the all of the there. That means we can say that there would be the complete replacement of the hydrogen with the help of the basic radical, and that's how we get the normal salt. Like they have given so many examples here. NaCl could be there, AgCl can be there. Fine, it's just that we have to find out different type of it. For example, student, if we are having AgCl, so it's like that if HCl is reacting with the Ag, so what we are getting, student, that the Ag, that you can say that the silver hydroxide can be used in this place. Okay, and that's how silver hydroxide, silver can replace the hydrogen from the HCl and we get AgCl. And always remember this thing, student, that the AgCl will having some white color of, you can say that white color of PPT would be there. Now you will say that, ma'am, what's the PPT? PPT, we call it as in our chemistry language, it's called as the precipitate. Precipitate, student, means when if like reaction is going on and if any compound is going to be settled down at the bottom of the beaker or test tube, then we call it as the precipitate. For so we can say that they are not completely soluble in the water or any other solution. For example, if I talk about NaCl, so if you are taking one glass of water and you are adding one spoon of NaCl in it and you are stirring it, so what you will observe, that all of the NaCl is going to be dissolved. But AgCl is having that white PPT, due to which you can say that it is not completely soluble in the water or any other solvent, we can say that. So that is the AgCl is different from NaCl on the basis of their solubility. We come to know what the solubility is, but I hope from this example you got that what is the difference between NaCl, that NaCl is completely soluble, but the AgCl is not completely soluble. You can say that it is springly soluble. That means partially soluble, you can also say. So that's how, student, these are the normal salt in which metal replace the hydrogen completely from the acid, and that's how we get the normal salts. Okay, I hope you got the point about the normal salt. Now coming to the second type. Second type is the acid salt. Now, from this name, what you can say that what could be the acid salt? Like normal salt is there, now acid salt. So you'll say, ma'am, if it is an acid salt, that means it would have some high concentration of acid part. That could be called as the acid salt. So yes, students, you are thinking absolutely correct. In which we can say the acid is having the more number of hydrogen, but sodium is that you can say that the metal is not able to replace all of the hydrogen from it, and that's how we are getting the salt which is called as the acid salt. Okay, it's not like that, student, that we are having acid only, hydrochloric acid. We are having different type of acid as well. For example, sulfuric acid is there. In sulfuric acid, student, what happened that it have the two hydrogen which can be donated. Exactly, like if I write down the H2SO4 here, so on complete dissociation, it will give 2H ions plus SO4 2 negative. So what the thing, student, that the sodium, that means the metal for the formation of the salt, has to replace all of these hydrogen. But when the condition comes that the sodium or the any of the metal is not completely able, like completely having that ability to replace all of the hydrogen, in that condition we get the acid salt. Okay, please look at the video.
SO4, copper sulfate, AgCl, silver chloride, etc. NaOH, sodium hydroxide, plus HCl, hydrochloric acid gives NaCl, sodium chloride, plus H2O, water. Acid salt. Acid salts are salts formed when only a part of the ionizable or replaceable hydrogen ions in a molecule of the acid are replaced by the metal or ammonium ion.
Okay.
NaHSO4, sodium bisulfate, NaHCO3, sodium bicarbonate, NaCl, sodium chloride, plus H2SO4, sulfuric acid, gives NaHSO4, sodium bisulfate, plus HCl, hydrogen chloride.
So, student, have you observed like when the metal is not having the capability to replace all of the hydrogen from it, that's how we get the acid salt. For example, NaCl could be there and H2SO4. Now, this is the metal. Now, this metal is not able to replace the hydrogen from here, so it will form NaHSO4 along with the HCl. And now, this salt, that is the sodium bisulfate, is called as the, we can say it as the acid salt. Fine. And you can also say that, student, in which the acid is stronger in nature, then we call it as the acidic salt. For example, if I give you one example, that this is the HCl, and if I'm having the NH4Cl, that is the, it is a weak base, students. Okay, please remember this point, that this is the strong acid but this is the weak base. So from here, students, what I am getting, so I am getting from here, it is the, oh sorry, I made a mistake, NH4Cl is going to be formed, it is a salt. And it would be NH4OH. Okay, so now what will happen, student, that this NH4, see student, NH4 is the ammonium ion which also present in the form of the positive charge. Okay, that's from here, if I see that the NH4 positive would be there, so this positive ion will replace the hydrogen from it, and what we get NH4Cl plus H2O. So you can see there is the strong acid and the weak base reacting with each other. Neutralization reaction is there, and we are getting NH4Cl, that is called as the ammonium chloride, and that is also called as the acidic salt, student. Why? Because here the strength of the acid is strong as compared to the base. That's why, students, we are calling it as the acidic salt. So I hope you got this point, that in what condition we can call it as the acid salt. First condition, when the metal is not able to replace all of the hydrogen from the acid, then we get the acid salt. And the second condition, when the strong acid react with the weak base, so what will happen, that the weak base is not able, like it is having the less strength, so what happened, that there would be the formation of the acidic salt. So this is the acid salt. Fine. Now if I want to ask you that, okay, we have discussed that this is the acid salt, but if we talk about base salt, so what would be the base salt? Now can you imagine that, okay, acid salt is that which is replacing the hydrogen, so or the strong acid would be there and weak base would be there. But if we talk about base salt, so what it could be, my students? I hope you can think about it. Go, like, you can do one thing, go in your kitchen and find it out, that which is the base salt. Exactly. See, what the thing is, we can't find ammonium chloride kept in our home, like in a form of it, that there is the container and it contains ammonium chloride. Exactly. So that's why you can't find it in your house. It's just that the sodium chloride is one of that salt which we get from, like, which we can easily find in our houses. So acid salt and basis salt we don't use in our household work. Okay. Now coming to the base salt, students. So first of all, please continue with the video.
Basic salt. Basic salts are salts formed by the incomplete neutralization of a base and acid. Hence, partial replacement of the hydroxyl group of the diacidic or triacidic base takes place. Example, basic lead hydroxide plus hydrochloric acid gives lead hydroxychloride and water.
Now, students, in the case of the acidic salt, what was happening, that the metal is not having the ability to replace all of the hydrogen from the acid. Now, the similar condition would be there. If we talk about base salt, bath salt is nothing. It's like base salt. You'll say, ma'am, what's the bath salt? Actually, bath salt is nothing. Okay, so coming to the base salt. So students, like if we see acid salt in that condition, so that this metal is not having the capability to replace all of the hydrogen. So now in this case of the base salt, what will happen, that the, if we talk about the acid or if we talk about the base, so for example, the base is there, it is the OH2 and we are reacting with acid. So what will happen, student? Like in this condition, there would be two OH negative ion. So this Cl is not having the ability, you can say that the non-metal, now we are talking about the non-metal, that the non-metal is not having the ability to replace all of the hydroxyl ion from here. That's why we are getting it as the base salt, that is the PbOH Cl, and along with what we are getting, student, like if it is the HCl is going to be replaced here, and it is the H2O from here. So that's how, students, you can see when the OH negative has been replaced, so it will form H2O. And that's how you can see that the non-metal is not having the capability to replace all of the hydroxyl ion from the base. That's how we are getting the acid, oh sorry, what we can say, that we are getting it as the base salt. Fine. So this is the first. Now if we talk about the similar method here, that if I take NaOH, and if I take acetic acid, that is the CH3COH, you know this thing, that the acetic acid is not a strong acid, whereas it is a weak acid. Fine. And it is a strong base. So when they two, like when they both are reacting with each other, so student, what will happen again, that this metal will replace the hydrogen from it. So it would form, that is the CH3CONA, which we called as the sodium acetate, plus H2O. Now in this condition it would be a base salt. Now why it is a base salt? So the same reason would be there, that the strong base is there, that is the NaOH is there, that is a strong base, and due to its strength is more as compared to the acid. That's why we are calling it as the base salt. So students, if we consider what's the normal salt, when the replacement is complete, like the replacement of the hydrogen from the metal is going to be complete, then we are getting the normal salt. Acid, when the metal is not having the ability to replace all of the hydrogen, then it form the acid salt. Or like if the strength of the acid is more as compared to base, then we get it as the acid salt. If we talk about base salt, so that all of the hydroxyl ions are not replaceable, that's why we got it in the form of the base salt. So these, till now we have completed the three types of the salts. Fine. Now coming to the another type of the salt. Okay, so that another type is the double salt. Now you will say, ma'am, what's the double salt? Like it's like NaCl and KCl. NaCl and what's the double salt? Okay, so see what's the double salt
Double
is.
salt. Salts formed when two simple salts are slowly crystallized out from a mixture of their saturated solutions. Example.
Yeah, I'll come to the example. But students, we can say that the double salts are those type of salt. For example, in a mixture, you are have, like in your solution, you are having mixture of many salts. So when any two salts or the simple salt crystallized from their solution or from their mixture, then we called it as the double salt. For example, you can see on the screen they have written the Mohs salt. Mohs salt is having the formula of FeSO4 NH4SO4.6H2O. Now, students, FeSO4 ferrous sulfate is one salt, ammonium sulfate is the another salt. So both are the salt, that is, both are the simple salt, but they are present in the form of the mixture in the solution. And when they are crystallizing, so we are getting two salts from there. That's how we call the Mohs salt as the double salt. And that's how we are having other type of double salt also. It's not just that it's the Mohs salt is there, we are having different examples of the double salt. But you got the point, that what we called as the double salt. So it's just that when the mixture is containing two simple salt and when they crystallized, so we get to it in the form of the double salt. That means two salts are present in that particular formula. In one formula we get two salts, and that's how we called it as the double salt. Fine, student. For example, dolomite. Dolomite is also an example of double salt, in which calcium carbonate and the magnesium carbonate both are present, and we get in the formula also. So that's how we get in the, like, two salt present in particular one formula, that is called as the double salt. So this is the classification of salt, students, till now what we have to study. Okay, so it's just that what's the salt? So salt, you can say that the salt generally prepared from the neutralization reaction, but we can also say that when the metal replace the hydrogen, and we get we get the salt from it along with the water. And then we come to know that the salt are of four types. One is the acid salt, base salt, normal salt, and the double salt. And I hope you got the difference between all of these four. So that's how the salt, the types of the salt has been completed right now. Okay, my students, now coming to the another part of this. So we have completed all of these. Fine. Now, okay, so now very important thing comes here, that what's the solubility of salt? That as I was talking to you about that the NaCl, you stir it and you will you'll get the complete solution, like complete solution of the salt. So what's the thing? So student, it is the solubility. Solubility means, you can say that it is that amount of the substance which you can add in the solvent so that the solution can become saturated. You know what's the saturation means? That means that if I'm taking, for example, I'm taking 100 ml of water, and if I'm adding 10 gram of salt in it, and after that the solution is going to be saturated, that means you can't add more of the salt in it. So that is the particular amount of the salt you can add in it. That means the solubility of salt, you can say that it's the amount of the substance soluble to make a saturated solution. That means it should be soluble in the water so that the solution can become saturated at a specified temperature and a fixed volume of solvent. It should not be like that, that the volume is changing. If the volume is changing, so exactly solubility will also change, but the solubility must be same throughout the the solvent must be, like you can say that the volume of the solvent must be same throughout this process, so that you will come to know that what could be the solubility of salt. Like I have given the example, you are taking 100 ml of water, and if you are adding that, after the addition of the 10 gram, you can't add the more salt in it, so that there would be, like you can say that there would be the precipitation or something like that. So at that point, it means that you just have to add such amount of salt or such amount of the substance so that it would be completely soluble into that solvent and the solution will become saturated. Fine. I hope you all understood that what the solubility is. It's not only about the salt, it is all about everything. That if we make the we prepare that what we prepare, that sugar solution. So in that, what happens, student, that if you are taking one glass of water, because what happened that the salts are having very tiny particles, so we can't observe it clearly. But if I talk about sugar solution, so we can observe it very clearly, and you can also do it you can do it at your home. That you are having one glass of water, you add one spoon, you stir it, it will get dissolved. Second spoon, you stir it, it will get dissolved. But when you add the third spoon of the salt, oh sorry, third spoon of the sugar, sorry if I was saying salt, so please ignore it, I was talking about sugar solution. So what you'll find out that there would be the crystals of the sugar at the bottom. Why? Because now the point has come that the sugar is not going to be dissolved in the water. Why? Because now the solubility of the sugar has been done. That means now it is having no more solubility in that water. So that's the solubility. That means when it is going to be completely dissolved into that particular solvent, so that the solution will become saturated. That means you can't add more of the solute in it. That is called as the solubility. And if we talk about solubility of salt, then in that condition the solute will be the salt only. So that difference is the about the nature of the solute. Okay, so the solute will be the salt. So that's how it is called as the solubility of salt, students. Now if we say that solubility, that how the factors changes the solubility of salt. Okay, so if we talk about here, that on the screen you can also see that the solubility changes with the nature of the substance. Now, what's the nature of substance you mean? If you remember, I was telling you about the sodium chloride and AgCl, that is the silver chloride. So the silver chloride is having the white PPT. So I have told you that it is springly soluble. That means it is partially soluble. So it also depends upon the nature of the substance which we are taking. If I am taking the sodium chloride, so it will give the more solubility because it is completely soluble in the water. But if I take AgCl, so what the thing, student, that it will form some of the precipitate at the bottom because it is partially soluble. So we are getting less solubility in that case. So it also depends upon the nature of the salt which you are taking, whether it is completely soluble or it is partially soluble, or it is like you can say that it is not going to be dissolved at any case. So that's how you can say the nature of the substance also matters. Fine. Now if we talk about second factor, that is the solvent. Now solvent, how you say that solvent plays the role in the solubility? See, students, like if the water is there and I want to dissolve salt in it, so it is going to be dissolved very easily because the water is polar in nature and the salt is also polar, so it will going to be dissolved in it very easily. But if I'm taking some salt which is not having that property that salt can be dissolved in it, so what's the condition, student, that the solvent is also responsible for the solubility. Fine. So the water we use generally for the solubility purpose for the salts. Exactly. Like if I'm taking any other solvent, for example, which is organic in nature, that means if I'm taking benzene or in liquid form or like carbon tetrachloride, so maybe NaCl is not going to be dissolved in it, because what the students, that the solvent also matters, that what type of solvent we are taking. So it's the nature of the substance and the solvent. Now the third point comes about the temperature. Okay, so students, like if, okay, again coming to that point about the sugar solution, that when you have at the third spoon, you see that the crystals are there at the bottom. They are not going to be dissolved. But if you transfer that solution in one of the pen, and so that you heat that solution, so what you find out that that the crystals which you are having at the bottom, they are also going to be dissolved. So that's the point, student, that if you increase the temperature, the solubility is going to be increased. Why, student? Because you will get more of the space in that condition, and that's how that's how the solute can dissolve very easily. And the same thing will be with the salt also, that if you are increasing the temperature, so the solubility of the salt also increases. Fine, students. So we have discussed about the three factors till now. But if I talk about the presence of common ion, now this point has to be understand very clearly, that what's the presence of common ion says. Okay. So, my dear students, we are discussing about solubility. Now, what we have to see is, we have to see the factor, that is the common ion effect. Okay, it's a like important topic, even though when you are going to a higher standard, so you will come to know that what's the common ion effect. And if you remember in the last video when we were discussing about the degree of dissociation, so I have told you what's the common ion effect. Okay, so we'll discuss it right now. Students, what happened, that for example, that see what I want to explain you right now, that in a glass or in any beaker, there is the water, and you have taken calcium sulfate. Calcium sulfate is the salt. Okay, so it will dissociate into what? It will dissociate into calcium ion plus SO4 2 negative ion. Okay, now what you are doing, that you are adding copper sulfate in it in the same glass. Okay, so what will happen? It will dissociate into copper ion plus sulfate ion, because you know this thing, students, that the compounds which are ionic in nature, they dissociate into the ions when we add them into the water. Fine. Now if one glass, that means I'm adding all of these in one beaker only, which contains water. Fine. So now dissociation will be there, and what you find out, that there is the sulfate ion, that the sulfate ion is more, because from the dissociation of both of them, what we are looking at, that the sulfate ion concentration is increasing. Exactly. So what I can see here, that the sulfate ion concentration increases at this point. Now due to which, student, what happened, if this concentration is increasing, so this reaction will go to the backward direction. You will say that why it is going to be backward direction, because, student, there is the one principle which is called as the Lee-Chatelain principle. According to that principle, what happens, that equilibrium, I have told you the about the equilibrium. So what happened, that when the reaction is at equilibrium, and if any changes has been done, so the equilibrium will move to that direction from like, so that the change will get nullified, and that is called as the Le-Chatelet's principle. So students, if in this condition the concentration is increasing at this side, so the concentration is increasing at this side when the reaction is at equilibrium. So now, according to that principle, what will happen, if the change is increasing at this side, so it will try to shift the equilibrium in its opposite direction, so that this change is going to be nullified. So that is why, student, the reaction will go in the backward direction, and if it is going in the backward direction, so what we are getting, we are getting calcium sulfate again. That means the calcium and the sulfate ion will combine with each other, and we are getting more of the calcium sulfate. That means the dissociation of the calcium sulfate is going to be decreased. And if it is going to be decreased, students, so what you can say, that if it is not present in the form of the ion, so it can't dissolve into the water properly. That means it will remain as the solid. Fine, because you know now that if there would be the ions, then it is going to be dissolved into the water. Exactly, because what happened if I talk about NaCl, so Na positive and Cl negative will form and they will dissociate, dissociate and dissolve into the water. But if the calcium and the sulfate is not present into the form of the ion, they are present in the solid form. So how it is going to be dissolved in the water? So it will remain as the solid only. So that is called as the common ion effect. So you can see, student, due to the presence of the common ion, according to the Le Chatelet's principle, that the equilibrium will shift to the backward direction because the change is increasing in this at this end, and that is why equilibrium will shift to the opposite hand so that both will be the same. Exactly, because what's the condition of equilibrium? That the both sides must be same, equal to each other. But if this side is going to be increased, so there would be some condition that there would be some process so that they both will become equal to each other, and then again there will be the equilibrium condition would be there. And that is the Le Chatelet's principle, students, that it will try to shift the equilibrium in that direction so that they would be equal to each other. Fine, and that is why we are getting calcium sulfate more in the solid form, and that's how you can say if it is in the solid form, and due to which what will happen, its solubility decreases. Solubility decreases. And even though, student, if I talk about alpha, that is the degree of dissociation, it is also going to be decreased, because what's the degree of dissociation? That we should get more and more number of ions so that the degree of dissociation must be high. If you remember, in the last video we have discussed about it. So that's how, student, the degree of dissociation will also decrease, because we are getting calcium sulfate more in the form of solid, and that's how solubility decreases, and it also, that dissociation also decreases. So that's the point of view of common ion effect for the solubility part. So, student, what's the solubility? That how much of the substance is going to be dissolved in the solution so that it will behave as the saturated one at specified temperature. Please note that it should be any specified temperature, because I have already told you, if you increase the temperature, so the solubility will also going to be changed. So that's the reason. And the common ion effect I have explained you right now. So this is the solubility of salt, and these are the factors which affect the solubility of the salt. I hope you all got this point. This is the new thing for you, I can say that. But it will be very helpful for you, because when you are going to a higher classes, definitely you are getting this in your syllabus, and that point you will say that, okay, I know what's the common ion effect, and that would be a very great achievement for you. I hope. Okay, now moving towards, oh, water of crystallization. See, student, what happened? The water of crystallization is a very common thing, not common thing, like a very basic thing, but generally people doesn't know about its correct statement, that what's the water of crystallization. Okay, so if I want to ask you one thing, that the copper sulfate, have you ever seen copper sulfate in labs or something like that? So, students, like in this picture, you can see that there are the different color of salts are present. So this blue one is the copper sulfate, because copper sulfate is having the blue color. Okay, when if I'm taking copper sulfate in one of the test tube, and if I heat that test tube, so what will happen, student? That copper sulfate from blue color is going to be converted into the white. Now, and you'll see that at the walls of the test tube there is some water vapors. So what we can say, that the copper sulfate contains some content of the water which is evaporating, and due to which the color of the salt is changing. Fine. But if again I add some water into the copper, that white color of the copper sulfate, so it is again showing the blue color. So what we can say, student, that due to the presence of that content of the water in the salt, it is showing the color, and that is called as the water of crystallization. So, students, if I say what's the water of crystallization for the copper sulfate, so it's just that, students, water of crystallization. So, students, it's like the that you can say it is the fixed number of water molecules. Fixed number of water molecules present in one unit of in one formula unit of salt. For example, if I talk about copper sulfate, so it is CuSO4.5H2O. That means the CuSO4 is having this 5 molecules of the H2O, and this 5H2O is called as the water of crystallization. That's the water of crystallization, WOC. Water of crystallization of the copper sulfate. And due to this presence of the water, there is some color in the copper sulfate, which is the blue color. But if this content of the water has been evaporated, so the color is going to be changed. Fine. And for example, the another case can be FeSO4. So it is FeSO4.7H2O. That means ferrous sulfate salt, which is green in color. And it is green in color because of the presence of this 7 molecules of water. And that's how this 7H2O is the water of crystallization for the ferrous sulfate. Fine. So what's the water of crystallization, student? That it's a fixed number of H2O of molecules present in one unit of salt, and it is responsible for imparting the color in the salt. Okay. So if someone asks you what's the water of crystallization of copper sulfate, so you'll say it is 5. For ferrous sulfate, it is 7, and it is different for different salt. Fine. That it is, you can say that it is the water molecules which is present in the water, oh sorry, water molecules which is present in the salt, so they are showing some color. So that's the water of crystallization. I hope you all got that what's the water of crystallization. Fine, students. Okay. You'll say that ma'am is just teaching so much, it's a heavy session, but you are getting so much of knowledge from it. Exactly, that different things are there. They are so interesting things that which we are we are getting from it. That okay, what are the salt? What happened as student, like if we say what the salt, so generally people think okay, it's salt, okay, namak hoga, that white salt which we use in our houses. But salt is not just a salt, and you have seen it right now: acid salt, base salt, double salt, even though there are different type of salt. Okay, so that's the thing. Now coming to the different part, not another part of this session. Okay, hygroscopic and deliquescent, what it is. See student, hygroscopic means that it is a type of the substance which is having the ability to absorb the moisture from the air, or you can say that the ability to absorb the water. And deliquescent is also the same thing, but there is some difference. We'll see that what the difference is. But first of all, if I ask you that why we require such type of material that which can absorb the moisture, so, students, what happened that generally when we do some reactions in our labs or in our industrial processes that we prepare something, so what happened that we require some of the material which should not contain any content of water or any moisture. So, we use such materials or substance which are hygroscopic in nature. So, what they will do, they will absorb the moisture from that particular substance, and that's how we get them for completely water free, or you can say that completely moisture free. That's why we use these substances. Now, you'll say, ma'am, what's the basic difference between the hygroscopic and deliquescent? So, my dear students, I'm having one video. Please look at it carefully. Okay. So, you'll come to know that what is the hygroscopic substance and what is the deliquescent substance. Okay, so he has written that his friend asked that what's the difference between these two. So So student, have you seen on the screen what they have written, that the hygroscopic substance are those type of substance which absorb the moisture from the air and convert themselves into the form of the paste, that they are not proper liquid but they are some kind of paste. That means we can see that okay, they are having water in it. For example, calcium hypochlorite, and in the picture you can also see that the paste is somewhat that this is in the, that you can see that that the hypochlorite solution, that is the calcium hypochlorite, it's somewhat having the paste like structure. Exactly, it's not completely liquid and not completely dry, but it is having some paste like structure. So that is the hygroscopic substance, student, which convert into the paste like structure after absorbing the water. Okay, now continuing with the video. See student, concentrated H2SO4 is also a type of substance which is acting as a hygroscopic substance, because it absorbs the moisture from the air. And what you will see that if it is absorbing the moisture, that means if it is absorbing some content of water from the air, so you will find out that it is going to be dilute. You remember now what's the concentrated and what's the dilute one? With dilute one which have some content of water in it. So that's how concentrated H2SO4 absorb the water from the atmosphere or from the air, and it will have some, like, it will going to be dilute by itself, and that is why it is called as the hygroscopic substance. Okay. Now, see students, what's the deliquescency means? It is that type of chemical substance which is having extreme hygroscopic property. Like you can see on this screen, it is completely liquid in nature. Whereas the hygroscopic substance are having some paste-like structure, they are not completely liquid. That means you can say that the deliquescency is that property of the substance which are having extreme hygroscopic property. That means they will absorb that much content of the water that they directly convert into the liquid form. So that is the delinquency and the hygroscopic. In hygroscopic, there will be the absorption of the water, but it is less. But in the case of the delinquency, it will be extreme hygroscopic property. That means they will absorb more and more water, due to which they will convert directly into the liquid form. Okay. For example, anhydrous ferric chloride. You will say, ma'am, what's the anhydrous? See, students, as I told you that all of these salts doesn't contain water content. So the salts which do not contain any water molecule, so they are called as the anhydrous salt. If I say that the copper sulfate is having blue color, so it is the hydrated salt because it is having content of water in it. But if I say copper sulfate is having white color, so it is anhydrous salt because it is having no content of water in it. So that's it. That is the deliquescency of the ferric chloride, anhydrous ferric chloride, that when it absorbs the moisture from its water, it directly convert into the watery form or the liquid form, and that's how we call it as the it is having the extreme hygroscopic property. Okay. Okay, so he's showing that the magnesium chloride is also used as the dry chemical, so that it is having the hydroscopic nature, that is the desiccant. See student, for the hygroscopic nature, we can use the different word, that is the desiccant. If someone is asking you what's the desiccant, so you can say that the desiccant are those substances which are having the hygroscopic nature. That means they can absorb the water, so like they can readily absorb moisture from the surrounding. Fine. So I hope you got the difference between the hygroscopic and the deliquescency. Okay, so that's the basic difference between these two, that the hygroscope, that it will absorb water but at less, at you can say that at a minor level, but the deliquescent materials will, or the substance will absorb the water, and extreme property they are having of the hygroscopic, that they directly convert into the liquid form. Fine students, I hope you got this point. Okay, now continuing with the video. Okay, not with video, with this session. Okay, so students, like we have discussed about the water of crystallization which salt contains, what are the basic property of the salt, that they are having the hygroscopic nature and the deliquescency. We have discussed all of these, and what is the salt as well. Now we are starting the different type of salts which we are having in our surroundings. So first of all, it's the sodium chloride, and you know that the sodium chloride is one of the most important salt which we required. So students, sodium chloride is the white salt because it do not have any water content in it. That is why it is white in color. Okay, and if I see how we prepared the sodium chloride, so the preparation you can see right now here, that HCl NaOH react with each other, neutralization reaction will be there, and that's how we get the sodium chloride, that is the NaCl. So this is the first preparation of the NaCl, students. Fine. So sodium chloride can be prepared from one of this method. Now the second method is very common method, if you know this thing, that how could we prepare NaCl. So, my dear students, if like, have you gone to beaches like near to sea, or have you ever tested the sea water? So, what's the taste of the sea water? Is it salty or is it normal water which we generally drink in our houses? Exactly, no. They are not having the same nature. Sea water is very salty. Exactly. So due to which what we can do, we can use sea water to prepare the salt. How we that you that if we are preparing salt from it, so what we can do, we can dig a pit and we can pour the sea water in it, and if there is the sunlight, so what will happen, that due to the sunlight they will absorb the water from it, and at the last we get the salt from that. So that's how you can say that due to the evaporation process of the sea water, we get the salt from the sea water because it is salty in nature, and that is the sodium chloride only which we generally use in our houses. So that's how you can prepare the sodium chloride. Fine. Now what can be the uses of sodium chloride, students? Okay, so starting with the uses of sodium chloride. Uses of sodium chloride. So first of all, it's just that we can use it as domestically, we use it as for cooking purpose. Second thing, student, that the NaCl which we are having, that we can use it like for preservative. Preservative, how, student, like whenever you have seen that your mother or your grandmother made pickle, so they generally add salt in it. Why we add salt in it? So that, student, that the pickle is not going to be damaged, or you can say that it is going to be preserved for a long time, so it can be used as the preservative also. Thirdly, how can we use NaCl? See, student, what happened, that some of the areas where the snowfall rate is very high, that means the roads, houses, all of them are covered with the snow. So at that places, to make the path, so what the people do, they put the salt there, because what will happen, salt will melt the ice, and that's how they can get rid of that snowfall. So you can say that the melting of ice can be done by using the NaCl. Fine. So these are some of the uses of NaCl, even though we are having many of it uses, but it's just that I can tell you this much. You can also find out the another uses of the NaCl. So that's how you can see that NaCl is a very useful thing in our daily life. Fine. Now coming to the another type of see, student, sodium hydroxide is not actually a salt, but it's in your syllabus. And see, student, sodium hydroxide is also called as the caustic soda. And how we prepare the sodium hydroxide, students? So if I tell you about the sodium hydroxide, sodium hydroxide is NaOH, okay, which we also called it as the caustic soda. Fine. And this caustic soda, that is the NaOH, has been prepared from the concentrated solution of the sodium chloride. That means concentrated solution of the sodium chloride, which we called it as the brine solution. Okay, just remember this thing. It can come in your exam, that, or in any of the Olympiad, in MCQ form, they can ask you what is the brine solution, and they will give you some of the option like concentrated NaCl, concentrated NaOH. So the exact answer is concentrated NaCl. So when it undergoes the electrolysis process, so from here, what I get? NaOH, I get chlorine, I'll get hydrogen, I'll get HCl. So many things we are getting from it. Okay. So now students, what's the major thing about this caustic soda? So from the concentrated NaCl, but it is undergoing the electrolysis process. So sodium hydroxide we are getting. This sodium hydroxide is very useful that we use it for the formation of paper. We use it for the formation of the soap formation has been take place with this base, and this base you can say if it is the base, so it is generally used for the preparation of antacid. Antacid means student which we use the medicines when we are feeling acidity, so that the acidity can get neutralized. So that is why we use the NaOH for the preparation of such compounds which are antacid in nature. Fine. Chlorine. See student, this chlorine is having very important what I can say use, that it can be used for the cleansing purposes. That means if I use, if, like we can use it as the disinfectant of the water. Generally what happened that the swimming pools, that are the public swimming pools, are there in water parks and there. So what the people there do, that the managing team of that water park or something like that, the team of their park, they will do that, they'll do cleaning of the water there on regular basis, because you can understand that like so many people are going there and all of them are there, so you can see that different people are having different problem. So their cleaning of the water must be there at a regular basis, so they use chlorine into the water so that it act as the disinfectant, and that's why chlorine is very helpful. Fine students. And if I talk about hydrogen, hydrogen is used for the preparation of fertilizers. Fertilizers can be prepared from it. It is used up there, and even though it is also used as the fuel in rocket. So that's how hydrogen is also having so many properties. HCl students, if I talk, HCl is used for the cleansing of the steel or something like that. So the HCl are also having their disinfectant type of properties. And again, if it is the acid, so it is again used for the preparation of the salt. Exactly, HCl and NaOH get NaCl. So that's how this is the sodium hydroxide student, which is having the many uses, because we are getting different type of byproducts. These all are the byproducts. Okay. Byproducts, what we understand by byproducts, that along with the product which we require to obtain, if we are getting something else from this reaction, so they are called as the byproduct. For example, chlorine, hydrogen, HCl, these all are the byproducts, and they are also having very excellent properties which we can use, so that we can use them. So this is the sodium hydroxide student, that is called as the caustic soda. Okay, so there are some questions. Why is sodium chloride required in our body? Sodium chloride, also known as salt, is an essential compound our body uses to absorb and transport the nutrient. What it will do, it will absorb the nutrient and it will transfer it, okay, and maintain the blood pressure, maintain right balance of fluids. So that is why sodium chloride is also very important inside our body. Fine. Name three chemicals made from the common salt or the sodium chloride. Now, this is your homework. You have to see that sodium chloride can be used to prepare some other type of chemicals also. And what could be those three chemicals? You'll say, ma'am, one of those is the caustic soda. Exactly, caustic soda and NaOH has been prepared from the sodium chloride only. So that is the one compound. Now you have to find out only two of them, and it would be the easy one. And even though you'll get the answer in the next session only, that what could be the three chemicals can be prepared from sodium chloride. So students, sodium chloride is the table salt, common salt. You can also say that, because it is generally used up in the houses. It is commonly present. Okay, student. So this much has been I have done for, like I have been scheduled for this class, that we are going to study about salt, some properties, what's the solubility, and hygroscopic, and because some of these salts are having water of crystallization. And now then we have started different type of salt like NaCl. NaOH is not a salt, but it is having so many uses, so that's why we are including it, because it is prepared from the common salt only. Okay. So students, If after listening this video or watching this video, you are having any question or any query, you can post your doubt over the forum on public or private forum as well. So that your query or your question will get solved and you will be happy about it. And I hope you'll like this video and keep learning from us, IITians. Thank you.